Hello students, so I hope you all are fine out there. So we are doing exercise 21E, prove trigonometrical identities, isn't it? So we have completed till question number 10 in our previous video, question number 1 of 10. So today we'll start from question number 11 onward, okay? So let's begin. This is question number 11 of 1, prove the following identities from exercise 21E. So we are asked to prove this equals to 2 tan A, isn't it? So let's copy left hand side. LHS equals to 1 plus sec A minus tan A whole square whole upon cosec A into sec A minus tan A, isn't it? Sec A minus tan A. So you know that 1 means sec square A minus tan square A. Since sec square theta minus tan square theta equals to 1, isn't it? We know this formula. So instead of this one, I can write sec square A minus tan square A. Okay, this plus comes here now, and sec A minus tan A whole square. Sec A minus tan A whole square. In the denominator we copy as it is, cosec A into sec A minus tan A. Now let us assume this sec A as A and tan A as B. Okay, so A square minus B square can be written as A plus B into A minus B, isn't it? A square minus B square equals to A plus B into A minus B. So A square minus B square is A plus B into A minus B. A plus B into A minus B. A square minus B square plus this plus comes here now, sec A minus tan A whole square. Sec A minus tan A whole square. So in the denominator we have cosec A into sec A minus tan A. Now you can see sec A minus tan A here also, and here also sec A minus tan A. So let us take sec A minus tan A common. Sec A minus tan A common. So now we had sec A plus tan A and sec A minus tan A here. So sec A minus tan A is taken common outside. So this sec A plus tan A remains within the bracket. Sec A plus tan A, isn't it? Plus this plus comes here. Sec A minus tan A is out. This sec A plus tan A comes here. This plus sign comes here. From here we had sec A minus tan A square, and one sec A minus tan A is taken out, then another sec A minus tan A remains within the bracket, isn't it? Sec A minus tan A. So in the denominator we have cosec A into sec A minus tan A. Now you can see sec A minus tan A in the numerator and denominator. You can cancel this. So this plus tan A and minus tan A can also be cancelled. So plus sec A and plus sec A. Let me continue here, okay. Plus sec A equals to 2 sec A upon cosec A, isn't it? So this is cosec A. Now this 2 remains here into, let us take this cosec A to the numerator, it becomes sin A, and this sec A to the denominator, it becomes cos A, because cosec and sin are the reciprocal of each other. Similarly sec and cos are the reciprocal of each other. So sec A when goes to the denominator becomes cos A, and cosec A when goes to the numerator becomes sin A, isn't it? So 2 into sin A upon cos A means tan A. Sin A upon cos A means tan A. So this is what we have in the right hand side, hence proved. RHS. So I hope we got this. Now let us do question number 12 of 1. So this question is very similar to question number 11. Okay, so we are asked to prove this equals to 2 cot A, isn't it? So let's copy question number left hand side of question number 12. LHS equals to cosec A minus cot A whole square plus 1 whole upon sec A into cosec A minus cot A, isn't it? So let's copy this as it is. Now 1 means you can write cosec square theta minus cot square theta instead of 1, isn't it? 1 means cosec square theta minus cot square theta. So instead of this one, I'm going to write cosec square A minus cot square A. Okay, so let me copy this as it is. Cosec A minus cot A whole square plus 1 means cosec square A minus cot square A. So in the denominator we have sec A into cosec A minus cot A. Now let me copy this cosec A minus cot A whole square as it is. Cosec A minus cot A whole square plus, let us assume this cosec A as A and cot A as B. So A square minus B square means A plus B into A minus B, isn't it? So A plus B into A minus B, A minus B. Okay, in the denominator we have sec A into cosec A minus cot A. Now you can see cosec A minus cot A here also cosec A minus cot A. So let us take cosec A minus cot A common. Cosec A minus cot A is taken as common. Here we have cosec A minus cot A square, isn't it? So cosec A minus cot A is taken common. So 1 cosec A minus cot A still remains within the bracket. Cosec A minus cot A. Cosec A minus cot A into cosec A minus cot A gives us cosec A minus cot A square. So this plus comes here. So this cosec A minus cot A is taken outside. Now remains cosec A plus cot A within the bracket. Cosec A plus cot A. Okay, so in the denominator we have sec A into cosec A minus cot A. Now you can see cosec A minus cot A in the numerator and cosec A minus cot A in the denominator. You can cancel this, isn't it? So this minus cot A and plus cot A also can also be cancelled. So let me continue this here now. This gives us cosec A plus cosec A. We have plus cosec A plus cosec A means 2 cosec A whole upon sec A, isn't it? Sec A. So if you take this cosec A to the denominator, it becomes sin A, and if you take this sec A to the numerator, it becomes cos A. So cos A upon sin A. Are you getting me? This sec A goes to the numerator and becomes cos A, and cosec A comes down to the denominator and becomes sin A, because sec A is reciprocal of cos A and cosec A is reciprocal of sin A, isn't it? So 2 into cos A upon sin A means cot A. This is equals to RHS. Hence proved. I hope you got this. Now let us do question number 13 of 1. Okay, this question is bit lengthy but very easy. Okay, we are asked to prove this equals to 0. So let us copy the left hand side first. LHS equals to cot square A into sec A minus 1 upon 1 plus sin A plus sec square a into sin a minus 1 upon 1 plus sec a. So we are asked to use this and prove this equals to 0. Okay. So cot square a can be written as cos square a upon sin square a, isn't it? Sin square a. Cot square a can be written as cos square a upon sin square a. Now we have sec a minus 1, sec a minus 1 upon 1 plus sin a, plus this sec square a can be written as 1 upon cos square a into sin a minus 1 upon 1 plus sec a. Okay. So let me multiply this cos square a with this sec a and 1. Okay. Cos square a into sec a, cos square a into sec a, cos square a into this sec a is written as 1 upon cos a, isn't it? So this cos a and 1 cos a from the numerator can be cancelled. So cos a into 1, cos a remains, isn't it? So cos square a into sec a is cos a. This means cos square a into sec a is cos a minus cos square a into 1 is cos square a. And in the denominator we have sin square a. We don't multiply, we just keep as it is. Okay. 1 upon sin a plus 1 into sin a minus 1 into 1, 1. Cos square a into 1 is cos square a plus cos square a into sec a is cos a, isn't it? Cos square a into sec a is cos a. So let's take the LCM of the denominators. Okay. The LCM will be sin square a. Let's take the common also from here. Cos a and cos square a. Cos a is common. So sin square a into cos a into 1 plus sin a into here cos a plus 1, isn't it? From this cos square a and cos a, I take cos a common here, cos a. So cos a into cos a, cos square a, cos a into 1 is cos a. So from this 2, I took cos a common, cos a plus 1 remains within the bracket, and this sin square a and 1 plus sin a remains as it is. Okay. So let me multiply this 2. Here I can take the common cos a. So cos a is taken common. So 1 minus cos a, isn't it? Cos a is taken common. So cos a into 1 is cos a minus cos a into cos a is cos square a. From these two, cos a is taken common into, isn't it? We need to multiply this 2, isn't it? While taking the LCM, because this whole thing multiplied with this gives us this whole thing. So this into this. From here we take cos a common into what remains within the bracket? Cos a, isn't it? Plus 1 plus, now we need to multiply these two numbers, isn't it? So sin square a into 1 plus sin a into 1 plus sin a into sin a minus 1, sin a minus 1. Okay. So cos a into cos a is cos square a. Now 1 minus cos a into 1 plus cos a, isn't it? 1 minus cos a into 1 plus cos a minus b into a plus b. This cos a plus 1 can be read as 1 plus cos a, 1 plus cos a, 1 minus cos a plus b, a minus b, means a square minus b square, 1 square minus cos square a. So 1 square is 1, so we need not write square instead in the power of 1. So 1 minus cos square a plus, okay, from here we have 1 plus sin a minus 1. We take minus sign common, so let me take minus sign common, and that minus into this plus becomes minus, okay, and this sin square a, so 1 plus sin a, this becomes 1 minus sin a, isn't it, after taking minus common. Minus 1 becomes plus 1, plus sin a becomes minus sin a. So 1 minus sin a into 1 plus sin a is a square minus b square. Are you getting me? After taking minus sign common, minus into plus is minus. This minus 1 becomes plus 1, and this plus sin a becomes minus sin a. So 1 minus sin a, 1 plus sin a, means a square, 1 minus sin a into 1 plus sin a, isn't it? So this is a minus b, a plus b, a square minus b square, a square minus b square, okay. In the denominator we have sin square a into cos a into 1 plus sin a into cos a plus 1, okay. We don't change anything from the denominator, we copy as it is. Let me continue the sum here. Now cos square a, we copy as it is, cos square a. So 1 minus cos square a is sin square a, isn't it? 1 minus cos square a means sin square a. This minus comes here. This sin square a we write as it is, sin square a. So 1 minus sin square a means cos square a. And in the denominator we have sin square a, cos a, sin square a, cos a into 1 plus sin a, cos a plus 1 into 1 plus sin a into cos a plus 1, cos a plus 1, okay, this cos a plus 1. So cos square a sin square a minus cos square a sin square a, these two numbers are same, cos square a sin square a, cos square a sin square a. This number is negative and this number is positive, so 0 upon this whole thing, sin square a cos a 1 plus sin a into cos a plus 1. So if the number in the numerator is 0, whatever be the number in the denominator except 0, okay, if the number in the numerator is 0, whatever be the number in the denominator except 0, the value will be 0. But please keep in mind, the number in the denominator should not be equal to 0, okay. If 0 upon 0, then this becomes undefined. This is not equal to 0, this is undefined. 0 upon 0 is not equal to 0. In the denominator, whatever be the number, but should not be 0, other than 0, other non-zero number. These numbers are non-zero number, so 0 upon non-zero number is 0, okay. 0 upon 0 is not 0, 0 upon 0 is undefined. So in fact there should not be a number like 0 in the denominator. If there is a number 0 in the denominator, whatever be the number in the numerator, 0 upon 0, please understand this, 0 upon 0 undefined, 2 upon 0 undefined, any number divided by 0 is undefined. So in the denominator there should never be a 0 number, there is always 1 or any other non-zero number in the denominator. But if the number in the numerator is 0, then whatever be the number in the denominator except 0, whatever be the number in the denominator except 0, then the whole thing becomes 0. So this is what we have in the right hand side, hence proved. I hope you got this. Now let us move on to the next question, question number 14. Okay, now let us do question number 14 of 1. Okay, so we have this in the left hand side and we're asked to prove this equals to 2 cos square a minus 1. So LHS equals to let us copy left hand side first. 1 minus 2 sine square a whole square upon cos to the power 4a. Okay, here we have a minus sine to the power 4a. 1 minus 2 sine square a whole square upon cos to the power 4a minus sine to the power 4a, isn't it? So instead of 1, we can write sine square a plus cos square a plus cos square a, because sine square a plus cos square a means 1. So minus this 2 sine square a, sine square a, okay, 2 sine square a comes here. So this whole thing is squared, isn't it? Whole thing is squared. Square. In the denominator we have cos to the power 4a minus sine to the power 4a. This can be written as cos square a whole square minus sine square a whole square, isn't it? So 2 2s are 4, 2 2s are 4. Cos to the power 4a means cos square a whole square, 2 2s are 4. Okay, so this cos square a, I write here cos square a, and this plus sine square a minus 2 sine square a means minus sine square a. Sine square a, 2 sine square a is negative, this sine square a is positive, so different sign means we need to subtract the number. We subtract sine square a from 2 sine square a, we get sine square a, the sign of the greater number comes here, and this whole thing is squared. Okay, so in the denominator we have, let us assume this cos square a as a and sine square a as b. Okay, so a square minus b square is a plus b into a minus b, isn't it? So a plus b into a minus b. A is cos square a minus b sine square a. So you can see cos square a minus sine square a in the denominator. Here also cos square a minus sine square a whole square, isn't it? So 1 cos square a minus sine square a and 1 cos square a minus sine square a can be cancelled. So in the numerator we have cos square a minus sine square a, isn't it? In the denominator we have cos square a plus sine square a. So this, in the right hand side we need cos square a. So let's convert this sine square a to the cos square form. Okay, so we have this cos square a here, cos square a minus sine square a means 1 minus cos square a, isn't it? Sine square a means 1 minus cos square a whole upon cos square a plus sine square a means 1, sine square a plus cos square a means 1, isn't it? So cos square a minus into plus, there is plus sign in front of 1, minus into plus, minus 1, minus into minus, plus cos square a. In the denominator we have 1, so no need to write 1. Every number has 1 in the denominator, isn't it? So this cos square a is also positive and this cos square a is also positive, so let's add this to 2 cos square a minus 1. So this is what we have in the right hand side, equals to RHS. Hence proved. So have you got this? Now let us move on to the next question. Question number 15 of 1. Okay, sec to the power 4a into 1 minus sine to the power 4a minus 2 tan square a. We are asked to prove this equals to 1, isn't it? So let's copy the left hand side. LHS equals to sec to the power 4a into 1 minus sine to the power 4a minus 2 tan square a, isn't it? So we copy this sec to the power 4a as it is. Now this 1 can be written as 1 square, isn't it? Let me put curly bracket here. Okay, so 1 can be written as 1 square, means 1 square means 1 into 1, 1 into 1 is 1, minus sine to the power 4a can be written as sine square a into whole square. 2 2s are 4. Sine to the power 4a can be written as sine square a whole square minus 2 tan square a. Now we have sec to the power 4a into, this one is considered as a and the sine square a as b. Okay, so a square minus b square means a plus b. Let me erase this curly bracket now. A plus b into a minus b, isn't it? A square minus b square means a plus b into a minus b minus 2 tan square a. Okay, so 1 minus sine square a is cos square a. Sec to the power 4a into cos square a into 1 plus sine square a. Okay, this 1 minus sine square a is cos square a. This 1 plus sine square a we copy as it is. Sec to the power 4a we copy as it is. Minus 2 tan square a. Now sec to the power 4a into cos square a. Sec to the power 4a into cos square a. Sec to the power 4a can be written as sec square a into sec square a, isn't it? Sec square a into sec square a gives us sec to the power 4a into cos square a means 1 upon sec square a. Cos square a means 1 upon sec square a. So let's cancel this sec square a from the numerator and denominator. We get sec square a into 1 sec square a, isn't it? So sec to the power 4a into cos square a is sec square a into 1 plus sine square a minus 2 tan square a. So sec square a means 1 by cos. So sec square a into 1 is sec square a. Okay, sec square a into 1 is sec square a plus sec square a into sine square a. Sec square a into sine square a is actually tan square a. Sec square a into sine square a. I'll prove this. Sec square a into sine square a is actually tan square a. How? Sec square a into sine square a means sine square a into sec square a, isn't it? That sec square a when goes to the denominator becomes cos square a. Are you getting me? Sec square a into 1 is sec square a. Sec square a into 1 is sec square a. This plus comes here. Now sine square a is here as it is. Sec square a into sine square a means sine square a sec square a. That sec square a goes to the denominator and it becomes cos square a minus 2 tan square a equals to, this is sec square a plus sine square a upon cos square a is tan square a minus 2 tan square a. Okay, now let me continue here. Oh, I can finish this here. Sec square a we copy as it is. Minus 2 tan square a plus tan square a is minus tan square a, isn't it? 2 tan square a is negative, tan square a is positive, so sign of greater number comes here. 2 tan square a minus tan square a is tan square a. Sec square a minus tan square a means 1, isn't it? Sec square a minus tan square a means 1. This is what we have in the right hand side, equals to RHS, hence proved. I hope you got this. Now let us move on to the next question, question number 16. Okay, this question is very similar to the previous one, question number 15, isn't it? So let's do this. We are asked to prove this equals to 1. So let us copy left hand side. LHS equals to cosec to the power 4a 1 minus cos to the power 4a minus 2 cot square a, isn't it? So let's copy this cosec to the power 4a as it is, cosec to the power 4a. So this 1 can be written as 1 squared, isn't it? So 1 squared minus cos to the power 4a means cos square a whole squared minus 2 cot square a. Okay, 1 squared means 1, cos square a into square means cos to the power 4a. So this is cosec to the power 4a, cosec to the power 4a. So a square minus b square. This means a plus b 1 plus cos square A into A minus B. A minus B. 1 minus cos square A. Isn't it? A plus B into A minus B. Minus 2 cot square A. Okay. So 1 minus cos square A is sin square A. So cosec to the power 4A into sin square A into 1 plus cos square A minus 2 cot square A. So cosec to the power 4A into sin square A is cosec to the power 4A into sin square A. Cosec to the power 4A means cosec square A into cosec square A. Cosec square A into cosec square A gives us cosec to the power 4A into sin square A means 1 upon sin cosec square A. Sin square A means 1 upon cosec square A. So let's cancel this one cosec square A and this cosec square A. We get cosec square A, isn't it? So cosec to the power 4A into sin square A is cosec square A. Cosec to the power 4A into sin square A is cosec square A into 1 plus cos square A minus 2 cot square A. Okay. So cosec square A into 1 cosec square A plus cosec square A into cos square A means cos square A upon this cosec square A into cos. Cosec square A into cos, cosec square A into cos square A is cos square A into cosec square A, isn't it? Cosec square A. This cosec square A goes to the denominator and becomes sin square A. Okay. So let us not write this here. Minus 2 cot square A. So this is cosec square A plus cos square A upon sin square A is cot square A minus 2 cot square A. Okay. So this is cosec square A plus cot square A minus 2 cot square A means minus cot square A. So cosec square A minus cot square A means 1 equals to RHS, hence proved. So this is question number 16. I hope you got this. Now let us move on to the next question. 17 of 1. Okay. We are asked to prove this equals to 2, isn't it? So let's copy left hand side. LHS equals to 1 plus tan A plus sec A, 1 plus tan A plus sec A into 1 plus cot A minus cosec A, isn't it? So let's convert this whole thing into sin cos form. Okay. So this is 1 plus tan A means sin A upon cos A. Tan A means sin A upon cos A plus sec A means 1 upon cos A. Let me put this bracket properly. So 1 plus cot A means cos A by sin A minus cosec A means 1 upon sin A. So we have 1 in the denominator of 1 here. Okay. So let's take the LCM of cos A and 1. The LCM will be cos A, isn't it? So cos A into 1 is cos A plus 1 into sin A is sin A plus 1 into 1 is 1, isn't it? Because we have cos A here also, here also. So here also we do the same thing. The LCM of 1 sin A and sin A is sin A. So sin A into 1 is sin A plus 1 into cos A is cos A minus 1 into 1 is 1. So now let's assume this cos A plus sin A as A and 1 as B. Okay. You can see here A plus B, A minus B, isn't it? Cos A plus sin A as A and 1 as B. A plus B into, bracket means into, a minus b. This means a square minus b square, a square minus b square whole upon cos a into sin a is cos a sin a, isn't it? We need 2, isn't it? So cos a plus sin a whole square means a square plus 2ab plus b square minus 1 square is 1. A plus b whole square, cos a is a, sin is b, okay. A plus b whole square means a square plus 2ab plus b square minus 1. This minus 1. In the denominator we have cos a into sin a, cos a into sin a. So let me continue here. Cos square a plus sin square a. This cos square a plus sin square a, okay. Cos square a plus sin square a, 1, isn't it? Cos square a plus sin square a is 1, plus 2 cos a sin a plus 2 cos a sin a. Cos square a and sin square a is 1 plus 2 cos a sin a minus 1. This minus 1 should not be forgotten. This minus 1 comes here, and in the denominator we have cos a into sin a, cos a into sin a, isn't it? So this plus 1 and this minus 1 can be cancelled. So we have 2 cos a sin a in the numerator, and in the denominator we have cos a into sin a. So let's cancel this cos a sin a from the numerator and denominator. We get 2. So 2 is in the right hand side, equals to RHS. Hence proved. I hope you got this. Thank you so much. I'll continue the remaining questions in the next video, okay?